So, we will continue our band theory of solids. So, we have seen that in crystal lattice points are there, atoms are there. So, if we consider one dimensional lattice, so their periodic potential one can consider. So, this periodic potential right. So, this potential, it is basically as per Schrodinger and Penny, as I have discussed. So, that was the potential, periodic potential one can consider for a crystal, and this height is V 0, and say if I take this the axis V x, okay, and this the x. So, this 0, this is A, this is minus B, this minus A plus B, this point, and this point A plus B. Okay. So, there is a periodicity is A plus B, and that V x potential for the, this is 0, this is 0 for x is greater than 0 and less than A, right, and this V x is V 0 for the range x is less than, x is less than 0 and greater than minus B, greater than minus B. Okay. So, this is the periodic potential is considered for a crystal one dimensional lattice, and this periodicity is A plus B, it should be V x. Okay. So, whatever potential, say V x equal to 0. So, here whatever potential here, so it will be at A plus B, at A plus B, here it will be same potential or minus A plus B, it will have the same potential. Okay. So, that is the periodicity, or one can just consider this middle of this and middle of this. Okay. So, that can be the also. So, that also A plus B. Okay. So, this about the potential that was considered by Koenig and Penny. So, that is why it is called Koenig-Penny model. So, whatever now we are doing, that is basically Koenig-Penny model. Okay. So, for this Schrodinger equation, we have to write Schrodinger equation A square cross square by 2m d2 psi by dx square plus Vx psi of course function of x equal to E psi x, right. So, this is the general time independent Schrodinger equation, and this is non-relativistic. Earlier I have not mentioned Schrodinger equation is basically non-relativistic equation, and relativistic equation, that is in quantum mechanics, that Dirac equation. So, we have two regions. In one region this potential is constant V0, and another region this potential is 0. So, we can have this d2 psi x by dx square, then plus, if it is Vx, if it is 0, if it is 0, then 2me by h cross square psi x equal to 0. So, that will be the one Schrodinger equation for the region x is greater than 0 and less than a for that region. Similarly, for other region d2 psi x by dx square plus, so this if I take this one, this I have to put V0. So, if I take this other side, so E minus V0. So, but I want to write V0 minus E. So, here minus sign 2m V0 minus E divided by h cross square, right, psi x equal to 0. Okay. So, this is for this region x is less than 0, but greater than minus b for this region. Okay. Now, let us, this is a constant, let me write somewhere. So, let us consider this alpha square equal to 2me h cross square 2me h cross square. Okay. So, this just I define this one. So, this I can write alpha square, and I will define beta square. So, let me beta square equal to 2m V0 minus E divided by h cross square. Okay. So, then I can write here beta square, right. So, now here I have for these two region this two Schrodinger equation. So, this say 1 and these 2. Okay. Now, we have to solve these two equation. So, for that what we do, we consider the wave function, proper wave function, we choose proper wave function. So, that for free electron theory, there e to the power minus k dot r. So, in our case for one dimension e to the power I k x, this plane wave, travelling wave. So, here it is basically free electron, but now we have introduced periodic potential, right. So, we can assume that, so for free electron whatever the wave function that is there, as well as another wave function say u x. So, that u x one can introduce. So, this u x, the potential, that this type of arbitrary function, looking at our problem. So, this I am not writing, just it is guided by Bloch, it is guided by Bloch, So, Bloch, he found that this for any periodic potential, the wave function will have two parts. One is this, and this one, this whatever one part is travelling wave or plane wave, and that will be modulated with another function which follow the periodicity of the potential, periodic potential. So, what does it mean? So, u x, that will be such that u x, it will be such that this u x plus this periodicity of this potential is here a plus b, okay, that will be equal to u x. Okay. So, that is the property of this function. So, it also, this function is periodic and it will have the same periodicity of this potential. So, this u x, it is called Bloch function. And one can prove it that this type of wave function satisfy any periodic potential, So, this, so in our case, so according to Bloch, so we have to take this wave function. Now, we have to adopt this wave function with our system, applying boundary condition, applying our this periodic potential condition. So, that we can do starting from this wave function. So, this, now this is the say psi x, our trial wave function, sometimes it is called trial wave function. Okay. So, So, from this function I can write that I can find out d psi by dx, d psi by dx will be equal to E. So, if I I k e to the power I k x u x plus e to the power I k x du by dx, right. So, then again differentiation d 2 psi by dx square. So, this again you can proceed. So, this will give, I think I will write there. So, I need space. Now, if I write d 2 psi by dx square equal to this one. So, again I k I square minus 1. So, minus k square e to the power I k x then u x, right, and then keeping I k e to the power I k x e to the power I k x. So, du by dx. Okay. So, now next part we will have here I k e to the power I k x du dx. So, basically this term I k e to the power this. So, I can put here 2, right, plus e to the power I k x d 2 u by dx square, e to the power I k x d 2 u d 2 by dx square, right, d 2 by dx square. See, it is not visible. I think I can, it is going out. So, plus e to the power I k x d 2 u by dx square, right, d 2 by dx square. So, now I can replace here what I can get from this here. So, just for these two equations. So, this periodicity here, this we can that u, we can take this travelling wave. Now, this modulated with this u. So, we can consider for this one equation for this one. So, here I can consider u 1 and this other one is u 2. So, I can write. So, I can replace this one by this, okay, and yes. So, what I will get? I will get minus k square e to the power I k x plus 2 I k sorry. So, here I will write E 1, it is a function of x, of course, and then plus 2 I k. So, I am replacing this part 2 I k e to the power I k x d u1 by dx, and then last part plus e to the power. So, this will be there alpha square psi x. So, I will write later on. So, this e to the power I k x d2 u 1 by dx square, right, plus alpha square psi x means this one e to the power. So, this also I have to shift this one plus e to the power I k x u 1 u 1. Okay. So, u1 it is function of x. So, I am not writing this one, just u1 I am writing. Okay. This equal to 0. So, this is for that region x is greater than 0 and less than a. Okay. Now, for this part, so here you can see I can write. So, every term contains, it is not plus alpha square psi x. So, it is alpha square, I think it is just alpha square. So, basically we can remove this, from each term, and then what else are common, I think then we can write this d2 u1 x square, d2 u1 by dx square. This term I have written, this term I have written, okay, and then this term du1. So, plus 2 I k du1 by dx, du1 by dx, and then I will have this term. So, here so this I have to d2 psi by dx square minus this. So, then I will have alpha square minus k square, right, u1 equal to 0. Okay. So, for another part I will get similar one, only difference is earlier it was plus alpha square psi x, now here minus beta square. So, minus sign is there. So, I will get same way d2. So, in this case u2 for this dx square plus 2 I k du 2 by dx square dx plus, so now it is beta square, right. So, minus k square it is there, now minus beta square. So, basically minus alpha minus beta square plus k square. So, I have taken this minus sign u2. Okay. So, that is equal to 0. So, okay. So, that is for 2 region, these two are for 2 region. Okay. So, I think I got the right one. Yes. So, now here what we have to do, I think this also I do not need. Yes. Okay, so now we have to put boundary condition. We have to put boundary condition that here you can see this part is basically it is equivalent to alpha minus k into alpha plus k. Here this term is equivalent to beta plus I k, beta minus I k, right. So, beta square minus I k square. So, I square will be minus 1. So, that way plus k square. Okay. So, here this is second order differential equation. So, from where you will get basically 2 root. Okay. So, if you have 2 root, so then your general solution. So, 2 root means for u 1 you will get 2 yeah. So, whatever this generally what I want to mean that e to the power say m x or I m x whatever, if I consider one solution for u, okay, for u, if I put here, so this second this is the second order differential equation. So, I will get basically here you can see m square etcetera. So, m I have to find out m square, this will give m, this will give 1. Okay. So, this, so from here you will get value, m value is something plus minus something. Okay. So, you will get basically 2 value. So, this 2 value basically from here one can guess. Okay. And general solution will be the that this sum of these two or 2 function. So, if it has 2, so say m 1, another you will get I m 2. Okay. So, general solution is written a this equal to a this plus b this. So, that is the principle of second order differential equation. Okay. So, following that one we can take this general solution for u. So, this for u 1, if I take general solution for u 1 equal to a e to the power I alpha minus k x plus b e to the power minus I alpha plus k. Okay. So, these two term as I mentioned it I have taken from here. Okay. And for this u 2, so I can write c e to the power I beta I k or k I beta. So, whatever, so I will write in my yes. So, this one I here yeah. So, beta minus I k So, I think I should write below, slightly below I should write u2 equal to c e to the power I beta minus ik x of course will be there plus d e to the power I minus I beta minus plus ik. Okay. So, this I can consider this a general solution, but this does not matter, because this I have to put here, okay, and this should satisfy this, and then proper form we will get. So, these are just general form, but as I mentioned, this one should look at your problem and try to guess a better function. So, there will not be much complication to reach to your particular solution. Okay. So, now this A, B, C, D are basically the constant. A, B, C, D are basically the constant. These are constant. Now, this value of this constant one can find out from the boundary condition, right. So, what are the boundary condition? I can say that boundary condition u1 at 0, because function has to be continuous. So, u1 at 0 equal to u2 at 0. So, both values should be same for at x equal to 0, okay. And their differentiation also has to be the differentiation also has to be du1 by dx at x equal to 0, it should be equal to du2 by dx at x equal to 0. Okay. So, this is the continuity, of a function at this point, and this it has to also satisfy the this periodicity. So, this u1 at A has to be equal to u2 at minus b, okay. Whatever here, so it has to be same as minus b. So, why I am writing minus b, or why this one? Because this equation, this is for x is greater than 0, less than a, and this for x equal to less than 0 and greater than minus b, right. So, when u1, so I have to take within this range. So, u1 a at this point, okay. So, that has to be same as that u2 at minus b, okay. Similarly, that differentiation du1 by dx at x equal to a has to be equal to du2 by dx at x equal to minus b, right. So, these are the boundary condition. Now, I have 4 boundary condition, 4 here, this from this. So, if I apply on these 2, then I will get basically 4 equation in terms of A, B, C, D, and if I, so 4 unknown, so 4 equation, so I will be able to find out this value A, B, C, D, okay. So, I think I will continue in next class. So, thank you for your attention.